Do you still remember measuring your height and weight in PE class to determine your body mass index? How about taking an exam? Have you ever wondered what is it for? These questions will be answered as we go along with this discussion. Let's talk about normal random variable and normal curve. Let's start with this given distribution. The distribution of height in centimeter of 16 grade 11 students in DPRO Senior High School Department. Construct a histogram for the random variable. Can you still recall classification of random variables? It can be discrete or continuous. What kind of random variable is the height? It is continuous because it can be measured. Also, the graph can be obtained like height or weight and the percentile rank of an exam with infinite values. The normal distribution. It is a powerful tool in statistics. A continuous probability distribution for a random variable x. It is the most relevant continuous distribution of probability in statistics. The normal curve is called the graph of a normal distribution, which means that the normal probability distribution is a probability distribution of continuous random variable. The following are the properties of normal distribution. Let's have the property number 1. The mean, median, and mode are all equal, based on the figure on the right side. What have you noticed on the shape of this figure? If your answer is that it looks like a bell shape, therefore your answer is correct. What does the center do with this figure? According to the second property, the graph of the normal distribution is bell-shaped curve, which is also called the normal curve, and is symmetric about the mean. When we say symmetric, both sides are equal with respect to the mean. And the third property is the total area under the normal curve is equal to 1, meaning to say, when we get the sum of both sides of the normal curve, therefore the sum is equal to 1. Now, let's have the fourth property. The graph of the normal curve are asymptotic relative to the x-axis. When we say asymptotic, it is nearly approaching but never touches the x-axis. What symbol do you see in the label below the normal curve? If your answer is standard deviation, that's the correct answer, which is the fifth and last property. Meaning, the curve is determined by the standard deviation of the distribution.
Means and standard deviations. A normal distribution can have any mean and standard deviation, meaning a normal distribution composed of mean and standard deviation. The mean gives the location of the line of symmetry. Okay, as you can see, based on the figure on the right side, we have the line of symmetry. The standard deviation describes the spread of the data. The mean and standard deviation. Example number 1. The mean is 85 with a standard deviation of 4. So now, I'm going to teach you on how to sketch the graph of the normal distribution given the mean and standard deviation. So here are the steps on how to sketch the graph of the normal distribution. So step number 1, draw a number line. Step number 2, locate the given mean on the origin of the number line. Step number 3, to get the values less than mean, subtract the given standard deviation from the mean. So, let's substitute the given value where the mean is 85 and the standard deviation is equal to 4. So, 85 minus 4 is equal to 81. Therefore, the values less than 85 is 81. In order to get the values less than 81, just continue the process. So, let us now proceed to step number 4. So, to get the values greater than mean, add the given standard deviation from the mean. So again, let's substitute the given values where the standard deviation is 4 and the mean is 85. So 85 plus 4 is equal to 89. Therefore, the values greater than 85 is 89. In order to get the values greater than 89, just continue the process. Since we have the values on the number line, so the fifth and last step is sketch the normal curve. For example number 2, just apply all the steps used in example number 1. Therefore, we have a normal curve. A normally distributed random variable with a mean of 0 and a standard deviation of 1 is called standard normal distribution or standard normal variable. It is presented using the standard normal distribution where the center of the curve is 0, which is the mean, and added 1 unit from the center to the right and subtracted 1 unit from the center to the left. So any x value can be transformed into z-score by using this formula, where z is the z-score, x will be the raw score, mu is the mean or the population mean, and delta is the standard deviation. This figure shows the conversion of normal distribution to standard normal distribution.
Let's proceed in finding the z-score of the given example. Mr. Jeffrey, a mathematics teacher, conducted a pretest on his subject. He wants to compare the pretest results of his students in mathematics and science subjects. The assessment results of grade 11 science and mathematics classes are as follows. Carlo had his exam on both classes. If he scored 90 in science and mathematics, which subject did he perform relatively better? Let's solve the z-score for science. Let x be the raw score, which is 90. The mean is equal to 88. The standard deviation is 4. And the missing is z-score. By applying the formula for z-score is equal to raw score minus mean all over standard deviation, then simply substitute the given values to the formula. Therefore, the z-score for science subject is 0.5. Now, let's have the solution for mathematics subject. Let x be the raw score, which is 90. The mean is equal to 87. The standard deviation is 5. And the missing is z-score. By applying the formula of the z-score, simply substitute all the values given. Therefore, the z-score for mathematics subject is 0.6. Since Carlos' z-score in mathematics is higher than his science z-score, it can be said that Carlo performed better in mathematics than in science. For example number 2, since the given values are mean, standard deviation, and x values, we should follow the process of solving used in example number 1. Therefore, these are the final answers. Now, these figures shows the conversion of standard normal distribution to normal distribution. The formula of normal distribution was derived from the z-scores formula. Now, let's proceed in finding the x values with this given example. Andrea, who is classmates with Carlo from example number 1, got a z-score of 1.20 in mathematics and negative 0.25 in science. What are her raw scores? Let's have the solution for science. Let z is equal to negative 0.25, mean is equal to 88, standard deviation is equal to 4, and the missing is x, which is raw score. Using the formula of normal distribution, which is x is equal to z-score multiplied by standard deviation plus the mean. Simply substitute all the given values to the formula. Therefore, the Andrea's score in science is 87. Now, let's have the solution for mathematics. Let z is equal to 1.20, the mean is 87, the standard deviation is 5, and the missing is x, which is the raw score. Again, applying the formula of normal distribution, then simply substitute all the given values. Therefore, the Andrea's score in mathematics is 93. Now, for example number 4, since the given values are mean, standard deviation, and the z-scores, we should follow the process of solving used in example number 3. Therefore, these are the final answer.
We can easily identify the area of the region under the normal curve by using the table under the normal curve, which also known as z-table. The value from this table will describe the area of the specific region of the curve to the left of the given z value. But have you wondered how are we going to use the table of areas to find the area under the normal curve? So let's have an example. For instance, we want to find the area to the left of 1.43. First, split the given value into two parts. One part is the ones and tens together and another hundreds. Then, the intersection of this number will be the area of the normal curve to the left of the z value. Therefore, the area to the left of z of 1.43 is 0.92364. Note that the area under the normal curve will always be less than 1, since the total area under the normal curve is 1. So now, let's consider a more organized way of finding the area by using the following steps. So for example, let's find the area to the left of z is equal to 1.12. Step number 1. Sketch the normal curve. Step number 2. Locate the given z-scores and shade the appropriate area. Step number 3. Use the z-table to be able to determine the area under the normal curve. Since we are finding the left area of z is equal to 1.12, we should follow the process of finding the left area used in previous example. Therefore, the area is equal to 0.92364. 64. Let's have the second example. So find the area to the right of z is equal to negative 2.97. So again, our first step is sketch the normal curve. Second, locate the given z-scores and shade the appropriate area. Third, use the z-table to be able to determine the area under the normal curve. Let's have the z-table again. First, split the given value into two parts. One part is the ones and tens together and another a hundreds. Then, the intersection of this number will be the area of the normal curve to the left of the z value. The area to the left of z is equal to negative 2.97 is 0.00149. So this can be subtracted from the total area under the normal curve. Therefore, the area to the right of z is equal to negative 2.97 is 0.99851. Therefore, the shaded area under the normal curve is 0.99851. For the third and last example, find the area between z is equal to negative 1.08 and z is equal to 2.14. So step number 1, sketch the normal curve. Step number 2, locate the given z-scores and shade the appropriate area. Step number 3, use the z-table to be able to determine the area under the normal curve. Since we are finding the area between z is equal to negative 1.08 and z is equal to 2.14, we should follow the step on finding the left area of z-score. But we should subtract the result of left areas from the two given z-scores. The left area of z is equal to negative 1.08 is 0.14007. And the area to the left of z is equal to 2.14 is 0.98382. So, 0.14007 is subtracted from 0.98382. Therefore, the area between z is equal to negative 1.08 and z is equal to 2.14 is 0.79813. Today's students have been a great learning experience. I am Sir Y,
And Sir Jeff,
your mathematics teacher.
remember, never stop learning until you reach your goals and dreams in life.